Anti-differentiate 4 over 7x in terms of x. Okay, let's have a look. Rules are, I'm going to say that is 4 times 7 to the power x minus 1. Okay, dx. Done anything? Just simplify it. Now I'm going to integrate. It's going to be 4, stays like that. 7x to the power minus 1 plus 1 divide by the new power minus 1 plus 1. Okay. Alarm bells, everything is closing down. Cannot happen because I cannot divide by 0. So does that mean that this doesn't have any antiderivatives? And the answer is no, it's not. We just can't use this method. So what are we going to use? I'm glad you asked, because if we look at the following, let's have a look at the following. Right, some of you might recognize this little sheet, and that was when we did differentiation. And we said that if I take y and I differentiate y, I'd find the derivative of y. Now the antiderivative then means that that's the inverse function, which means I am working backwards to get the same answer. Just like addition is the inverse function of subtraction, which means I'm going to get back to the same value. What happened when we differentiated ln x? When we differentiated ln x, the answer was 1x. I had an x underneath the line, just as I have here, which means if I integrate this, I should get this. And that is then where our following rule comes from. Right, our next rule will be this rule. If I have 1 over x, then the derivative or the integral of that will be ln x plus c. Okay, so the 7 doesn't really matter. I'm going to apply the same rules as what I did previously. So let's just have a peek on how to do that. So what I'm going to do, so can you see not do this, don't do this. This was just to show you, don't do it, never, ever. You can't. So if I find the integral of 4 over 7x dx, I can say, right, this equals, and we will have our next example will be where this is a function and this is a function. So what I'm going to do is I'm going to say, if there's a function in x underneath the line, this will be the 4 stays there. 4 ln of this function 7x divide by the derivative of this, which is divide by 7. Okay, plus c. Now, the reason I accept this is the following. Let's have a look. We're going to have 4, this is then 4 over 7 ln 7x plus c. Now, some people say that's the same as just having ln x. And why is this equal to 4 over 7 ln x plus c? And the reason for that is they are the same because of the following. I can take this and I can apply my log laws, and I can say this is 4 over 7 multiplied by, and because this is multiplication, this is the same as ln 7 plus ln x plus c. Now remember, this c value can be anything. If I multiply this out, I'm going to get 4 over 7 ln 7 plus 4 over 7 ln x plus c. 4 over 7 ln 7 is a constant value. It is a value which, if I add to that, just becomes another constant value, which is then the same as saying 4 over 7 ln x plus c2, although it doesn't have to be c2, but it's just another value. And this is why this is the same as this just because of that C value, the fact that we can split ln up. So I will accept any one of those two questions. What you could have done to get this right from the start is to go back to the beginning. And I'm just going to do it in another color. Is if I go back and I do the one from the top, I can say 4 over 7x dx is the same as, and I can break this up as 4 over 7 times 1 over x dx. It's multiplication, so in its multiplication, I can actually move this 4 over 7 out of the integration sign, and then I have 1x over dx. And then I can say, well, this is then 4 over 7 ln x plus c. So I get to the same answer, and I explain to you why it is. So I'll accept any one of these as a correct answer.